Now that you can see me, it means that we're ready. Headsets are on, adjustments are done. Are we ready? Let's do a final check. All right then, welcome. Let's begin. Currently, we're at a hatchery owned by Nagi's company located in Dreshka, Hungary. Shortly, we will have an enjoyable tour which I think will capture your interest. During this tour, we will go through in ovo vaccination process and we'll have the chance to see in action the innovative technologies used to facilitate the process and maximize hatchery output. Let me introduce first Nagi's hatchery. It produces 40 million broiler chicks per year. The hatchery we are currently in processes about 50 million eggs per year. There are 4 transfer days per week that lead to 4 hatch days. Now, let's begin our tour together. We are currently in the area called the transfer room, where embryonated eggs on their 18.5 days are candled, and transferred from incubator trays to hatching trays. If you take a look around, you can clearly see the high standard of hygiene in this transfer room. Hygiene is of utmost importance during transfers, especially when in ovo vaccination is conducted. It is clearly visible how strict hygiene measures are implemented here to reduce the risk of cross-contamination. The transfer process is fully automated. As you can see behind me, thanks to automation, egg candling, in ovo vaccination and egg transfer from incubation trays to hatch baskets are conducted almost with no human interaction. Automation reduces the labor force required, improves process speed and flow, and has negligible egg breakage compared to manual operations. Shortly, we will have the chance to have a look at this process in detail. But first, let's have a look at the area where everything begins. Now we're at the egg reception area. The hatchery receives hatching eggs from different breeder farms. At the reception, its sanitary status is verified to avoid incubation of eggs with poor eggshell quality and high risk of contamination. Then they will be submitted to a second fumigation process. The first one is done at the farm. Fumigation process is extremely important in order to prevent pathogens from entering the hatchery. It also aims at destroying the microorganisms on eggshells to avoid them from entering the eggs. Once the eggs are fumigated, they are ready to be stored. During storage, temperature and humidity levels must be closely controlled to avoid variations. However, there are 2 ways to receive the eggs: in transport trays or in incubation trays. If eggs are received in transport trays, they have to be transferred to incubation trays before fumigation and storage. Egg transfer to incubation trays can be performed manually or with automation. In this hatchery, it's a manual operation. To maximize hatchery output, ensuring the egg is set properly in the incubation trays with the blunt end up is a must. Eggs set with the small end up are called upside-down eggs, and its prevalence will depend on the automation level and the egg setting process and the shape of the eggs. In manual operation, the prevalence of upside-down eggs increases due to human error. When hatching eggs are set by a rolling system, prevalence of upside-down eggs is lower, of course. But still, some error is expected due to round eggs. On average, upside-down egg prevalence is estimated in 1 to 3% of the yearly hatching egg production and represents a direct loss in hatchability and chick output. In this hatchery, the prevalence of upside-down eggs has been solved completely. Thanks to the innovative OvoSense egg setting analyzer you can see behind me, upside-down eggs in the trays are identified and marked with a 99.9% accuracy. This way, the eggs that have been marked can be corrected before incubation. Remark that upside-down eggs will not hatch regularly, and if they do, they are normally discarded as cull chicks. This technology is a huge progress for the quality control of egg setting process. Let's analyze in detail the upside-down eggs phenomenon. Eggs are properly set when their blunt end is pointing upwards. An embryo's head will develop towards air chamber in the blunt end, and it will use the oxygen in the air chamber to breathe during pipping. However, when eggs are set upside down, the air chamber will be pointed away from the embryo's head, and unfortunately during the pipping phase, the embryo cannot reach the oxygen. Nevertheless, the automatic egg setting analyzer such as the innovative OvoSense allows the operator to turn the eggs in the right position before incubation and gives the chance to hatch 100% of the fertile eggs. In a scenario with a yearly production capacity of 60 million eggs with an 83% average hatch and 1% of upside-down eggs, the correct setting of this 1% of upside-down eggs thanks to OvoSense represents nearly an upside of 500,000 chicks per year. This is a large number if upside-down eggs prevalence is at 3%, the figure reach 1.5 million chicks per year. Outstanding. In hatcheries with medium and large capacities, and regardless, the eggs are set manually or by rolling systems, ensuring the proper egg setting and incubation trays is a must to maximize hatchery output. In this context, OvoSense is an unrivaled quality control tool that offers a simple and effective egg setting analysis and therefore a fast return of investment. We're back to the transfer area. At 18 and a half days of incubation, hatching eggs are transferred to hatch baskets, but first eggs are candled and vaccinated in ovo using the innovative cutting-edge laser life and egg inject system you see behind me. Thanks to the laser life technology, the dead and contaminated eggs are removed before injection, and therefore only live embryos are transferred to the hatchers. Consequently, it improves day-old chick health and helps with antibiotic-free production, thanks to reducing contamination. Let's look closer to what makes laser life stand out from traditional candling equipment. We've reached the highlight of our tour, the Egg Inject in ovo vaccination system. Shortly before, eggs containing dead and contaminated embryos had been detected by the laser life candling and removed from the incubation trays. At this point, only eggs that contain live embryos will be vaccinated in ovo using the consolidated in ovo technology, the Egg Inject system that you see behind me. Processing speed of the standard Egg Inject system is 60,000 eggs per hour. Compact Egg Inject with a processing speed of 25,000 eggs per hour is also available in the range for small and medium-sized hatcheries. Egg Inject dual injection system is designed to be safe. It's a patented technology allowing automatic and individual adaptation of the injection depth to each single embryo, regardless of the egg size and flock age, and adaptable also to all types of incubation trays. It's the perfect tool for modern hatchery vaccination. First of all, eggs are disinfected before the injection to maximize the biosecurity control and minimize the risk of contamination. Then, hatching eggs are ready for in ovo vaccination. First, high pressure is used to perforate the eggshell. As the pressure is applied only to a very small area of contact, the incidence of eggshell breakage is negligible. Once the needle is inside the egg, the system changes to low pressure and adapts the injection depth to each single embryo. The individual adaptation of injection depth minimizes the embryo injuries caused by an excessive intra-embryo perforation. Thus is designed to be safe. Right after the injection, each injector is disinfected to minimize the risk of cross-contamination. Thus, a double disinfection system is completed. Finally, hatching eggs move forward to the transfer system. Now, let's have a closer look at the in ovo vaccination itself. Currently, we're an egg containing the live embryo in an incubation tray after laser live candling. Peroxide-based sanitizer is being applied to the eggshells in the first phase of disinfection. We've reached in ovo vaccination with egg inject dual pressure injection system. Firstly, high pressure is used for a clean and precise eggshell perforation. Then, low pressure is used to adapt the injection depth and deliver the vaccine in the target amniotic location. Right after, a chlorine-based sanitizer is applied to disinfect each needle after injection. The small eggs are also vaccinated in the same manner. Thanks to dual pressure system, injection depth is adapted to deliver the vaccine in the target location through a light embryo perforation and reducing the risk of excessive intra-embryo injection. No matter the size of the egg or position of the egg, injection depth is adapted to each single embryo. Injection depth adaptability represents a major advantage compared to traditional fixed depth technologies where injection depth is fixed and might cause excessive intra-embryonic injections leading to potential hatchability losses. We're ready to transfer eggs that have been vaccinated in the right embryo compartment with an accurate vaccine dose applied at high speed. Eggs contain only living embryos as the dead and contaminated eggs have been removed. They're being transferred to the hatcher baskets as you can see behind me. The goal of all the effort spent so far and the innovative technology involved here is to maximize hatchery output. Through the removal of dead and contaminated eggs at transfer and an accurate in ovo vaccination under highly hygienic conditions, healthy and protected chicks hatch, able to express their full genetic growth potential at farm level. Today, we had the chance to witness an outstanding hatchery process made possible by cutting-edge, innovative technology. We saw that technology is the application of scientific knowledge for a practical purpose. In an in ovo context, egg inject technology is designed as a safe, consistent and accurate method of vaccine application and represents major benefits for poultry producers worldwide. In a production context, OvoSense technology is designed to ensure the proper egg setting while Laser Life improves day-old chick health and helps with antibiotic-free production thanks to reducing contamination. In a highly competitive market where antibiotic-free production is an additional constant pressure, the use of innovative technology is the most competitive way to optimize hatchery output.